In this video, we will learn how a cloudburst occurs. You have to understand that a cloudburst usually occurs near a hilly region. Why? Because mountains are the only landform that are closer to clouds, and cloudburst basically means bursting of a cloud. If a cloud bursts near a mountainous region, then the impact is much higher compared to any plain area. You must be aware of how clouds are formed, right? When the land and water surface gets heated up due to solar energy, it creates a low pressure zone. As the temperature increases, the air also becomes warm. Air expands when it is warm, and that makes the air rise because hot air molecules are loose. After reaching a certain height, warm air starts to cool and loses its capacity to hold water vapor. This is called condensation. That is how clouds are formed. Once clouds are formed, if the density of the cloud increases, the next step is precipitation. Now what you have to do is bring mountains. So imagine a mountainous region. You can think of northern part of India. As it is, the months of June, July and August are the summer season in the northern hemisphere. That means temperature is pretty high and humidity increases. So as the land surface warms up, the temperature of the surrounding air also increases. That causes humidity. Humidity means the amount of water vapor in the air. If there is more water vapor in the air, we also call it moisture. Now the moisture carrying air moves towards the Himalayan region where the temperature is comparatively low. When warm air rises, it does not rise in an absolute straight upward pattern. Because there are winds that flow horizontally, that means the direction is a little sideways. Now the exact answer for this can be found in the laws of thermodynamics. So what the laws of thermodynamics tells us is that heat moves from areas of higher temperature to areas of lower temperature. That means heat can move anywhere, up and down, sideways, depending on the situation. And the situation is the temperature difference. Temperature difference is really what drives heat to move in any given direction. That is how the warm air of northern India moves towards the Himalayan region during the summer season. As the warm air moves towards the Himalayan ranges, or you can say hilly terrain, if you can recollect, it will remind you of orographic rainfalls. I have a separate video where I have explained different types of rainfall. In that I have explained about orographic rain. I will again explain briefly here. There are two sides of a mountain, windward side and leeward side. Windward means the side of the mountain which faces a lot of wind. As a result, this side of the mountain faces a lot of rainfall. And the leeward side is the opposite side, where it is dry and there is no wind. That means there is very little rainfall. During the summer season, the Indian side of the Himalayan mountains becomes the windward side. So when warm air carrying moisture moves towards a hilly terrain, and by the way, even the mountain surface will heat up during the summer season. However, the mountain will also lose heat faster than the valley floor, and that's what makes the mountains cool. Now the warm air of the valley rises and moves towards the Himalayan colder region. We know that the troposphere is cold, but it's very high up in the sky, somewhere around 15 km high. Before the warm air reaches the troposphere, at the mid-altitude, the warm air gets attracted towards the colder region that exists at the top of a mountain. Himalayan mountains are snow-capped mountains. It is cold at the top. We know that Himalayan mountains do not touch the troposphere. They are not 15 kilometers high. On average, these mountains are around 5 to 8 kilometers high. That too I'm talking about the Greater Himalayas. When warm air rises upward along the slope of the mountain, warm air then starts to cool because atmospheric pressure decreases with altitude. As the warm air begins to cool, the water vapor present in it starts to condense. Then clouds begin to form. It forms a vertical column of clouds known as cumulonimbus clouds. The reason they are formed in a column is because they are unable to move as quickly as the continuous incoming of the moisture from below. As a result, they start to get tightly packed with each other. If you look at this cloud, cumulonimbus, it is a combination of cumulus cloud and nimbus cloud. I have a video on different types of clouds where I have explained everything in detail. You can watch it if you want to know in detail about different types of clouds. Both these clouds are usually formed at a lower altitude of around 3 to 7 kilometers. I'll put a picture of these two clouds. Cumulus clouds are fluffy like cotton, but then they have a flat base. It looks as if a piece of cotton is floating in the air. Their color ranges from white to light grey. And if you look at it carefully, somehow it also looks like a cauliflower. On the other hand, nimbus clouds are black or dark grey in color. These clouds are usually formed at even lower altitudes, around 3 kilometers or so, and sometimes they are even nearer to the surface of the earth. Since the color of these clouds are black or dark grey, that makes them dense, and these clouds block the rays of the sun from reaching the surface of the earth. Nimbus clouds do not have any specific shape. However, they are thick and dense. So naturally, it consists of a large amount of water vapor. So next time when you see any cloud getting darker, most probably it will rain. Now, a vertical column of clouds known as cumulonimbus clouds appear at a height of 3 to 5 km. If you look at the recent cloudburst in Dharamshala, Dharamshala is located in Kangra Valley, in the shadow of the Dhauladhar mountains. Dhauladhar range is part of lesser or middle Himalayan chain of mountains. The height of Dhauladhar mountain ranges vary from 3 to 5 kilometers. If you look at the height, it is somewhat similar to the height at which nimbus and cumulus clouds are formed. These clouds contain large amounts of water vapor. When these clouds stop at one place and water droplets within the clouds begin to mix together, the density of the clouds increases greatly with the weight of the drops, and then suddenly it bursts. Since these clouds burst at a higher elevation, the rainwater does not stop on the mountain. So the water comes down along with mud and stones. That is why you see extreme rainfall, thunderstorms and flash floods, which cause a lot of damage. Even the 2013 Uttarakhand floods is an example of this kind of phenomena. So basically, cloudburst occurs due to orographic lift of warm air parcels that forms cumulonimbus clouds, and then these clouds burst and heavy rainfall occurs that further triggers flash flood and destruction.